Driver drowsiness is a major global problem, contributing to 20 to 30% of road crashes and causing hundreds of thousands of deaths annually. In the US alone, it causes 72,000 crashes, 44,000 injuries, and 800 deaths per year. Research shows that sleeping less than 7 hours in 24 hours increases crash risk by twofold. These statistics highlight the urgency of addressing driver drowsiness. In the US, it costs $109 billion annually in lost productivity, property damage, medical expenses, and legal fees. These statistics highlight the urgency of addressing driver drowsiness to reduce its impact. AITS engineers have shown that driver drowsiness can be detected with high accuracy levels, up to 99% with CNNs trained over cAInvas. Implementing such a system can help reduce driving drowsiness incidents and prevent up to 17% of fatal crashes, according to a study by the National Institute of Standards and Technology. AITS engineers have developed a low-code platform with templates for detecting driver drowsiness using AI computer vision techniques and machine learning algorithms. This involves training a model on a dataset of images of different types of driver drowsiness poses and then using this model to classify new images of driver drowsiness objects. The model is trained with different types of convolutional neural networks combined with transfer learning with pre-trained deep learning models with an accuracy of over 99%. The deep learning model is easily created by collecting pictures and driver drowsiness in a dataset on a TinyML platform like cAInvas with preprocessing that includes normalization and augmentation, and training the model resulting in an accurate model that is compiled with deepC. The resulting application is ported to a small computer like NVIDIA Jetson Nano or Raspberry Pi connected with a camera that runs with no internet connection in remote areas like farming, so you can easily carry it in your pocket to identify the driver drowsiness yourself or help farming neighbors. Driver drowsiness is a problem that can lead to road crashes and pose a threat to public safety, and its accurate detection is challenging due to subjective symptoms, physiological variability, and limited data sources. Following URLs are referred to in this video. Check the description for the links. Contact us.